Imagine a universe where most of what exists cannot be seen or directly detected. It's like trying to understand the wind by watching leaves rustle or detecting an invisible scaffold holding a house together. Welcome to the mysterious realms of dark matter and dark energy, the unseen forces that shape our universe. Let's start with dark matter, the invisible glue holding galaxies together. Astronomers first suspected its existence when they noticed something puzzling. Based on the visible matter, like stars and gas, the outer edges of galaxies should spin much slower than the inner parts, like how the outer edge of a carousel moves slower than the center. But that's not what happens. The outer stars in galaxies move just as fast as the inner ones. This defies what we'd expect from gravity if it were only influenced by visible matter. Enter dark matter, an invisible substance that doesn't emit or absorb light but has mass and exerts gravitational pull. It forms a massive invisible scaffold that holds galaxies together, stopping them from flying apart. Dark matter doesn't just hold galaxies in place, it also bends light. This effect, called gravitational lensing, happens because dark matter's gravity warps space itself. Think of it like a transparent magnifying glass in space, distorting and amplifying the images of far-off galaxies. These cosmic funhouse mirrors reveal the presence of dark matter even though we can't see it directly. Now let's shift to an even stranger force, dark energy. While dark matter holds things together, dark energy pushes the universe apart. Scientists discovered this in the 1990s when they studied distant supernovae, stellar explosions used as cosmic mile markers. They expected to find the universe's expansion slowing down due to gravity. But instead, they found the opposite. The expansion is accelerating. It's as if some mysterious force is acting like an anti-gravity, driving galaxies away from each other at increasing speeds. Think of dark energy like the yeast in bread dough. As the dough rises, the space between the raisins, galaxies, expands. The raisins themselves don't move much, they're just carried apart by the dough. In our universe, dark energy is the yeast, causing space itself to expand faster over time. So if we compare dark matter and dark energy to everyday experiences, dark matter is like the invisible wind holding leaves on a tree, unseen but tangible through its effects. Dark energy is like helium in a balloon, making it rise and stretch the universe outward. But how do we detect something we can't see or touch? For dark matter, we use indirect evidence like galaxy rotation curves, gravitational lensing, and experiments in underground labs that try to detect weakly interacting particles, or WIMPs. For dark energy, scientists study the cosmic microwave background, supernovae, and large-scale cosmic structures to measure how space is expanding over time. Despite these advances, dark matter and dark energy remain enigmatic. Dark matter, we don't know what it's made of, particles, primordial black holes, or something entirely new. Dark energy, is it a property of space itself or something dynamic like a new field or force? These are some of the biggest unanswered questions in modern science. Dark energy has profound implications for the universe's future. If it continues accelerating the expansion, galaxies will drift so far apart that the night sky will darken over billions of years. This big freeze scenario suggests a cold, isolated future for the cosmos. Thankfully, the quest to understand the dark universe is far from over. Missions like the Euclid Space Telescope and experiments like the Large Hadron Collider are probing these cosmic mysteries, and with every discovery, we move closer to understanding the forces that govern our universe. The dark universe challenges our understanding and ignites our curiosity. It reminds us that even in darkness, there is light waiting to be discovered. Join us on this journey to uncover the secrets of dark matter and dark energy. Subscribe now, and together let's explore what lies beyond.